Assalamu alaikum. Today I want to present on connection between eigenvector and She matrix. First of all, let's know about eigenvector. Generally, in linear algebra, an eigenvector of a linear transformation is a non-zero vector that only changes by an overall scale when that linear transformation is applied to it. Let's see and define it formally. If T is a linear transformation and V represents an eigenvector, in that case the lambda shows an eigenvalue that where we can be received based on eigenvalue. Also, if we consider an n-dimensional vectors that are formed as a list of n-scalars, such as the three-dimensional vectors down there, also can be considered as eigenvector. So eigenvector can also, we call it matrix, but 2 by 1 matrix or 3 by 1 matrix, meaning the column should always be 1 and the rows can be many. And the lambda actually represents eigenvalue related to an eigenvector. Moving forward, eigenvector example is shown in this figure. Let's see that x actually represents an eigenvector. So A here represents actually any matrix multiplied by x. So the lambda here actually represents an eigenvalue. It can be any value. And also next issue for our topic is She matrix, because we are trying to find the connection between She matrix and eigenvalue. So now we are going to define She matrix. She matrix is actually an elementary matrix that creates or produces new points or another eigenvector based on the current point. Later on we will see the example. A She matrix is also known as identity matrix with an additional variable in it. So the form of She matrix also looks like an identity matrix, except we have an additional variable in it. A general form for the She matrix can be written like this. We have A, B, C, D. So in this case, the B and C here actually shows off diagonal. We call it off diagonal terms, which can be one of them can be changed or get any value, but other should get 0. So let's see if the B produce if B get any value, meaning it produces a shearing in the x-axis, or if C gets any value and B is 0, in that case it produces a shearing in the y direction, like here. In this case, lambda meaning it can get any value, but in this case lambda comes here and 0 go up there. So this is an example for She matrix. Let's say in this case we have originally 4 points, the original points. So after it moves to, in this okay, this example it actually changes based on y-axis. So meaning the shear is produced in the y-axis. So the main point is actually to find the connections, or what is the relevance between eigenvectors and She matrix. So the first point to be noted is that for every She matrix, the eigenvalue is fixed and only one, which is 1. This is the one connection. Always for a She matrix, the eigenvalue is 1. There is no need to find any other eigenvalue for it. We cannot find any other. Second, if shearing point is on the x-axis, meaning that it change into this form, where the eigen will lie on the x-axis, because only the x-axis will get changed and other one will remain unchanged. So the third point is if shearing point is on the y-axis, meaning that In this case, the eigenvector will lie on the y-axis, and only the y-axis value will change, and other will remain unchanged. So the other point to be noted is that Shay matrix multiply the current point always produce a new eigenvector of point. So when we multiply any current point or eigenvector by Shay matrix, it will produce a new eigenvector. Actually, always produce a new eigenvector. Or if we multiply two eigenvector for the sake of finding Shay matrix, it will still give us Shay matrix. So here is some example that we put. The first one is, let's say, change or producing sharing and the x-axis. So in this case, this is the first example where the x-axis remains sorry, actually this is y, changing the y-axis, and this is changing the x-axis. If you look at the figure here, so actually here this the value of x-axis is 0, meaning the x-axis will remain unchanged, and the y-axis will always change. So in figure it will look like this, meaning these 2 points is also shared by this after multiplying the Shay matrix. And also this example shows change in the x-axis, where these 2 points is still remain unchanged, but here it is changed on the x-axis. So that's all. Thank you very much.